Good morning once again and welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And in this video, I want us to explain something that is on page 76 of Pure Mathematics 4. And we are still dealing with integration, chapter 6. And in this video, we want to further discuss integration by substitution. And in this question we are asked, this is example 8 and part B. Use integration by substitution to evaluate this expression. And of course, once we have this, we can decide, or rather in the question will give us let u be equals to 1 plus the sign of x. We have decided u to be this part which is under the square root, so that now du dx is simply going to be the cosine of x, and the cosine of x, and that is just exactly what we have. So when we have the cosine of x, it means now du can be expressed to be du is equals to the cosine of x dx for that matter. So you can already see that that part, the whole of this part by itself, cos x dx is going to be du. And having said that, now we need to express what we have here. So there is nothing left. All what we need to do is to realize that whatever is under the square root is u. So we can establish now the integral. We need to change the limits, but even before we change the limits, we're going to talk about u raised to power a half, which takes care of the whole of that part, then cos x dx, which is du. But let's talk about the limits now. We have been told that u is equals to 1 plus sine x, and the limits we were introduced with in the original question are the limits as far as x is concerned. So we need, now that we are integrating u, or with respect to u, we need to acquire new limits. And what is it? So x and u. Initially we had x being equals to 0, but what is u? u is 1 plus sine x, which is going to be sine 0, and sine 0 is practically 1. Of course, sine 0 is 0, 0 plus 1, sine 0 is 0, 0 plus 1, we get 1. And we had the value of x being equals to pi over 2, and what is u? 1 plus pi, or sine pi over 2. Incidentally, sine pi over 2 is 1, and 1 plus 1 is definitely a 2. So with that, we can say that we have already changed the limits, and our integral is going to be equals to the integral from 1 all the way to 2 of u raised to power half du. And what we have now is just direct to integration, and we can already have the integral is going to be u raised to power 3 over 2 over 3 over 2, which is 2 over 3. And of course, we have now 1 and 2. That is it. The moment we substitute u with 2, then we have 2 over 3, 2 raised to power 3 over 2 minus 2 over 3, 1 raised to power 3 over 2. And the moment we have limits now substituted, what we have to remember is that we have 2 raised to power 3 over 2 is the square root of 2 raised to power 3, which is the root of 8, which means the integral is 2 over 3, the root of 8, minus 2 over 3, the root of 1 cubed, which remains 1. Now, as far as we can already see that 2 over 3 is common, so we're going to have something to do with 2 over 3, which is common outside the bracket, root 8 minus 1. And what is root 8? Root 8 is simply root 4 times root 2, which is 2 over 3, open bracket, root 4, root 2 minus 1. But root 4 is perfectly a 2. So we are going to have 2 over 3, open bracket, 2 root 2 minus a 1, which is now the final submission. At least we cannot simplify this further, but that is it. This is the integral, having used substitution, integration by substitution. And that is the end of example 8 part B. Let us all work together. Subscribe to my YouTube channel widely and let us discuss mathematics further. All right?